I come back with another tutorial. So this is question 8 from tutorial sheet 1. I know a lot of you want to know how to solve these questions. These are very simple and straightforward. So before I can start solving, I would like to remind you to say subscribe to my channel. Just click on that button which says subscribe so that you don't miss out the videos that I'm going to be posting. So that you don't miss out the solutions of the oncoming tutorial sheets that you're going to be receiving from your lecturer. So click on that button which says subscribe. Okay, so the question here is telling us to say prove that the following are irrational numbers, and then we have the first one here which says we have to prove that the root of 3 is an irrational number. Now, before you can do what? Before you can start solving these questions, you first need to know about 4 rules that apply when we talk about irrational numbers: the addition, subtraction, multiplication, and division of irrational and rational numbers. So these are the rules here. The first rule is that the addition of 2 irrational numbers results to an irrational number. So when you add 2 irrational numbers, you are going to have an irrational number as your answer. Same applies to subtraction. When you subtract 2 irrational numbers, the result is going to be an irrational number. So addition and subtraction of 2 irrational numbers will always give you irrational numbers. And then the third rule here says multiplication and division of 2 irrational numbers results to either an irrational number or a rational number. So multiplication and division of 2 irrational numbers results to either an irrational number or a rational number. And then the fourth one, which is the last one but not the least, there are also others, but these are the most important ones. Addition and subtraction of an irrational number and a rational number results to an irrational number. So when you add an irrational number and a rational number, the answer is going to be an irrational number. When you subtract an irrational number and a rational number, the result will always be an irrational number. Yeah. And then there is also another one which says it's impossible for you to add 2 irrational numbers and you have your answer to be a rational number. It's impossible. Yeah. Same applies to subtraction. You can't subtract 2 irrational numbers and your result becomes a rational number. Alright, so let's proceed. So this is our question here. This is question 8 in your tutorial sheet 1. So this is MSM 111. So the first question is telling us to say we prove that the root of 3 is an irrational number. So the first thing that you need to know here is which method am I going to use. So in our case here, we're going to use contradiction method. So contradiction method, the way it operates is we're going to assume that the root of 3 is a rational number, and then we're going to, since we know the rules for rational numbers and irrational numbers, we're going to assume that the root of 3 is a rational number. We just make an assumption. So let us assume that the root of 3 is a rational number. So if the root of 3 is a rational number, this simply implies that the root of 3 can be expressed in the form a over b. We know to say only rational numbers can be expressed in this form, a over b, where a and b are members of integers and b should never be equal to 0, and a and b are co-prime factors. So a and b are co-prime factors. What do we mean? Meaning a and b are in their lowest form, meaning this fraction a over b has no factor. There is no number that can go into a, there is no number that should go into b for this root of 3 to be called a rational number. Yeah. So from here we now need to start solving. Now, how do we solve? or how do we prove? So what you need to understand is that you have to get this part. Yeah, so I'm going to get this part. Okay, let me just see if at all there's an option of changing ink. Okay, there's no white. Alright, let me use white. Yeah, so the root of 3 is, if the root of 3 is a rational number, then this root 3 should be able to be expressed in the form a over b. So now let us try by all means to get rid of this square root. So how do we do that? We do this, and then we square both sides like that. So once we square both sides, we're going to remain with 3 this side. 3 is equal to, and then here what is going to happen is we're going to have a raised to power 2 is going to be a squared over b raised to power 2 is going to be b squared. So here what we do is we cross multiply. This is just the same as 3 over 1. 3 times b squared. First let us start with this one. A squared times 1, we get a squared. This a squared is equal to, and then 3 times b squared, we get 3b squared. 3b squared. So here what we're trying to say is this a, when you look at this a squared is equal to 3b squared. Meaning for you to get a squared, you have to multiply 3 times b squared. In other words, 3 can go into a squared, b squared times. I don't know if you have gotten that. 3 can go into a squared, how many times? B squared times. This is the reason why we're saying 3 times b squared, we're getting a squared. So here what we can say is we can conclude to say a squared is equal to a squared is divisible by a squared is divisible. We can say a squared is divisible by 3. So we can conclude to say a squared is divisible by 3. In other words, 3 is a factor of a squared. 3 is a factor of a squared. Maybe let me write it that way. It will be easier for us to understand. Let me just say 3 is a factor of a squared. Okay, so we're going to say 3 is a, so we're going to say 3 is a factor, 3 is a factor of a squared. So 3 is a factor of a squared. And then from there we can also see that if this 3 is a factor of a squared, this 3 can also then go into a. So in other words, we're trying to say that 3 is also a factor of, so 3 is also a factor of a. How do I know that? So mathematically, if you have this expression like this, if you have this expression like this, simply means, okay, for instance, let's get maybe, for instance, we have, this is just an example which I'm giving here. If you have maybe 6 squared, oh sorry, I'm writing cubed instead of squared. So if you have 6 squared, so 6 squared will give you what? 36. 6 squared will give you 36. So 6 squared is equal to maybe 3, let me say 3 times which number, I think, okay, let's say for instance maybe we have here maybe we have, what is 9 times wait, okay, yeah, anyway, I would have, if I had known, I would have made an example so that I show you, but this is mathematically correct. So when you are multiplying a square with any number and then the answer gives you another square, it simply means that this number that you're multiplying with this square is a factor of this other square, and then this same number again is a factor of the square root of that number, meaning 3 is also a factor of a. So for you to find 3, or rather for you to find for you to find a, in other ways, we are trying to say for you to find a, this means that you are going to multiply this 3 by a constant number k. So for you to find a, you need to multiply 3 times k. So 3 times k is going to give you 3. I mean, it's going to give you a. So what do I mean, or what do I want to do, or what does this imply? It implies that if I have this a is equal to 3k, if I replace this 3k where there's a squared there, I'm going to have something like this. 3k, I'm going to have something like this, 3k squared being equal to 3b squared. So when I simplify this, I'm going to have 9k squared being equal to, this will be 3b squared. And then when you divide this 3 into that 9, you are going to have b squared being equal to 3k squared. So we've gone back to the same expression which looks as this. So this implies that 3 again is a factor. So 3 again is a factor of, so I'll just, okay, is a factor of 3 again is a factor of b squared, and then this 3 again is also a factor, so 3 again is also a factor of 3 again is also a factor of b. So now from our assumption here, if you check properly, we said a and b should be co-prime factors. A and b should be co-prime factors, and I explained to say co-prime factors. This implies that this fraction is in its lowest term. There is no number which is supposed to go into a and b for this root 3 to be a rational number. Now, since so now the way you conclude here, is just that I don't have anything to use for writing here, but I think let me do my best to conclude here. So the conclusion will now be that, sorry, let me just do this. Okay, yeah, it's going to be that since 3 is a factor of both a and b, then this contradicts with the fact that a and b are co-prime factors. So this is now contradicting, since we have discovered to say, let me just do this. Since we have discovered to say 3 is a factor of a, 3 is also a factor of b, meaning this is now contradicting with our statement here, which says A and B are co-prime factors. So this is how you conclude your question. This is how you write your final answer of your question. After doing this, you show all these steps and then you come and conclude in this way. So in other words, using contradiction method, after writing this statement here, all you need to do is just to find a fault. You find an error, you find a statement which is contradicting with one of these statements here in this line. Alright, so I think you have understood, because here is straightforward. You just need to conclude to say, since 3 is a factor of both A and B, then this contradicts with the fact that A and B are co-prime factors. Right, so this is simple, straightforward. Let us quickly move on to the next question. Alright, so even this question here, this one here, you also use contradiction method. How do you use contradiction method? So here, the most important thing that you need to know here is that you need to remember the rules that we talked about. These rules: addition of a rational and an irrational number gives what? So here what you do is you just have to prove that this root 2 is an irrational number. You just say taking root 2. You say taking the root of 2, meaning you just take the root of 2 out of this statement, and then you say assume, you make an assumption, assume that the root of 2 is a rational number. You make an assumption. Sorry, it's difficult to write using a mouse. So you make an assumption to say, assume that the root of 2 is a rational number. Okay, so after making an assumption, you write that statement which says if the root of 2 is a rational number, meaning this root 2 is we can write this root 2 in the form A over B, where A and B are members of what? Integers. This is what you write. And then B is not equal to 0, and then apart from that you say A and B are co-prime factors. A and B are co-prime factors, or are in their lowest term. So that's what you say. After writing this, you start proving that the root of 2 is irrational. So once you prove that the root of 2 is irrational, at the end you just come and conclude to say the addition, because you know that 1 is a rational number. So you conclude, after finding that the root of 2 is irrational, you now come in and conclude to say the addition of a rational number and an irrational number gives out an irrational number. Hence 1 plus the root of 2 is irrational. Yeah, the addition of a rational number which is 1 and irrational number which is root 2 gives an irrational number. Hence 1 plus the root of 2 is an irrational number. Same applies to this question here. It's also straightforward. How do you solve this? Simple. You prove that the root of 3 is irrational. You also prove, you say taking root 3, you prove the root of 3 as an irrational number, right? And then you also come and get the root of 2. You prove it separate to say root 2 is an irrational number. After proving that root 2 and root 3 are irrational numbers, you come and conclude using this point here, which says addition of 2 irrational numbers results into an irrational number. So when concluding, you just say, since the addition of 2 irrational numbers gives an irrational number, hence the root of 3 and hence the addition of the root of 3 and the root of 2 gives us an irrational number. We just say the root of 3 plus the root of 2 is an irrational number. Now I know somebody may ask themselves to say, how about this question? This one is simple and straightforward. It's even the simplest on these questions. How do you do this? Remember the time we did the SADs? Yeah. If you don't have the video for SADs, you can just scroll up on my channel, you find it. So when you have something like this, you just need to rationalize this for you to work it out properly. How do you do that? So you are going to find the conjugate of the denominator. And then what is the conjugate of this denominator? So you just change the sign between there. So it's going to be 1 minus the root of 2. And then this same conjugate, you multiply it both on top and down there. So this is what you are going to do. And then when you multiply down there, when you multiply up, we start with the numerator first. 1 times 1 minus the root of 2, you eventually get the same 1 minus the root of 2. This is what you are going to get. But when you multiply the denominator there, you can see that this is giving us the difference of 2 squares. So how do you multiply the difference of 2 squares? You just say 1 squared minus, and then this you say the root of 2, and then you also square this, the root of 2 squared. So this is what you are going to get. So 1 minus 2 over, sorry, this is not supposed to be 3 but 2. Yes, 1 minus 2 over 1 squared, you get 1, and then minus the root of 2 squared, you get 2. So what you get here now, you have 1 minus the root of 2 over 1 minus 2, you get negative 1. So here what you have now as your answer will be, when you divide that, you get negative 1 plus the root of 2. So meaning the final answer here will give you the root of 2 minus 1. So this is how, so it's advisable when you are writing numbers, you start with a positive number. Yeah, so this is what you are going to get. So after now simplifying it to this format, you know what, here you have not answered the question, here you have just simplified the question. Now you can start proving that this given question here is an irrational number. How do you do that? You first have to prove that the root of 2, so you say taking the root of 2, and then you prove that this root 2 is an irrational number. After proving that the root of 2 is an irrational number, you come back to the what's this? You come back now to the rules that we learned, which says subtraction of, addition and subtraction of an irrational number, and a rational number results into an irrational number. So when you subtract this rational number, when you subtract a rational number from an irrational number, you still get what? An irrational number. So you just know how to phrase your conclusion, yeah, so that it makes sense. So thank you very much for watching today's tutorial video. Please make sure that you don't forget to subscribe to my channel so that you don't miss out the videos that we're going to be posting on this channel. Yeah, subscribe. Because those that have subscribed, they are doing what? Every time I post a video here, they are able to see it. So if you haven't subscribed, that's the reason why you can't see the video that I've posted there. Subscription is free, you don't have to pay anything. So click on that button which says subscribe, and then you enjoy the videos that I'm going to be posting. Shalom, shalom.